Hi everybody, today we're going to be looking at probability tree diagrams.
First, if you haven't already watched part 1, then make sure you do that first. I went over what tree diagrams are, and I also covered an example of tree diagrams using independent events. Now on to this video.
Let's see what we do or how we make the tree diagram if we have dependent events. Alright, so dependent events means that the probability of one event depends on the probability or the outcome of another event. So the question here that I have says there is a 60% chance that it will rain today. If it rains, the probability of watching a movie is 0.5. But if it doesn't rain, then the probability of watching a movie is 0.3. What is the probability of watching a movie today? Okay, so if you think you can do this by drawing the tree diagram and everything, then pause the video and try to do it yourself. Otherwise, let's do it together. Okay, so to start off, we have two sort of clear events or outcomes happening. The first one is rain, right? So the probability of watching a movie depends on the rain. If it rains, then we have a different probability for watching a movie. And if it doesn't, then we have a different probability for watching the movie. And the question says, what is the probability of watching a movie today? So this, you can't just put down, 0.5 or 0.3. That would be wrong because when it asks you what is the probability of watching a movie today, then we have to consider both scenarios, when it rains and when it doesn't, and we have to give sort of a conclusive answer, keeping in mind or after having considered both the situations. So to start off, we know that the probability of rain depends. We know that the probability of watching a movie depends on the probability of rain. So our first two branches are going to be for the rain, right? So the first outcome is going to be that it rains. And the second is going to be the complement of rain complement. And this is something that you may see, which is why I'm going to introduce it now. If I have something like rain complement, that means that it doesn't rain, all right? So there's a 60% chance that it will rain today. So I'm going to put 0.6 on this branch. And if you remember the rule before, we said that the probabilities of the branches must add up to 1. And though they don't explicitly tell us what the probability is of not raining, we know from the rule that it has to be 0.4. Okay, so we have this first part settled. Now let's continue. If it rains, okay, so we're looking at this outcome. If it rains, the probability of watching a movie is 0.5. Okay, so again, we have two branches. First one is watching a movie, and the other one is complement of watching a movie or not watching the movie. All right. If the complement sign is sort of confusing you, then you can, you can just cancel it and write not to watch, something like that. That's totally fine as well. Okay, so the probability of watching a movie is 0.5. So I'm going to put 0.5 here. And they don't tell us this probability explicitly, but again, we know from the law that this has to be 0.5 as well because we want them to add up to 1. Okay, so now we have this part sorted. The next part, it says, but if it doesn't rain, so now we're looking at this outcome here, then the probability of watching a movie is 0.3. So again, I have two outcomes, watching and not watching. Okay, so the probability of watching a movie is 0.3, which means this branch, the probability of this branch should be 0.7, right? So now we have our whole tree done. The question is, what is the probability of watching a movie today? So we don't care about specific cases of it rains or it doesn't. We want to know the overall probability of watching a movie. So that means it could either rain and you watch a movie. So this could happen. This could happen, right? It rains and you watch a movie, or it doesn't rain and you watch a movie, right? Either ways, both of these end up in you watching a movie, and so these are the outcomes that we care about, okay? I'm just going to delete this because it makes it a bit messy, but I hope you've understood that these are the two outcomes that we care about, this one here and this one here, okay? So let's see the first one. How do we get the probability of raining and watching a movie? Go back to the rule, and if we go across branches, we have to multiply. So the probability of raining and watching a movie is going to be 0.6 times 0.5. Okay, 0.6 times 0.5. And that is equal to 0.3. Okay, and then this branch now, the probability of not raining and watching a movie is going to be 0.4 times 0.3, 0.4 times 0.3, which is 0.12. Okay, so the total probability, now we're going vertically downwards, so we have to add the two cases. That's going to be 0.3 plus 0.12. So the total probability of watching a movie today is 0.42. If you want to check whether the tree diagram you've made is correct or not, you can do that. All you have to do is you have to find the probability of each of these outcomes. So this was 0.3. This is going to be 0.6 times 0.5. Same thing, 0.3. This one is 0.12 as we calculated. And this one is going to be 0.4 times 0.7. 0.4 times 0.7 to 0.28. And all you have to do is you have to add up these probabilities and make sure that they add up to 1. Okay, so 0.28 plus 0.12 plus 0.3 plus 0.3. And these probabilities sum together does give us 1. And so you know that you haven't made a mistake and that your tree is correct. Okay, so I hope this was helpful and thank you for watching.